Hello everyone, this is your tutor AB. Today we're going to be solving a problem from the May 2019 IB Mathematics examinations. This is an additional higher level problem from paper 1. It's worth 6 marks and is actually relating to related rates. Let's get started. A camera at point C is 3 meters from the edge of a straight section of a road as shown in the following diagram. The camera detects a car along the road at t is equal to 0. It then rotates, always pointing at the car until the car passes O right here, the point on the edge of the road closest to the camera, which is right there. Okay, a car travels along the road at a speed of 24 meters per second. Let the position of the car be x and let OCX, this angle, be theta. Find d theta by dt, that is the rate of rotation of the camera in radians per second at the instant the car passes the point O. One thing to know about related rates question is, as the name suggests, we need to find a relationship. We need to find a relationship in this scenario. Meaning, let's see. What is the shape that I see, right? I know that this 3 meter, the distance from the camera to the road, is constant, right? It never changes. So can I create some relationship or an equation that has a relationship that relates the angle to some distance? Well, we can see that a right angle is being formed. So can that not be my relationship? A right angle relationship? Let's see. Let me draw a diagram. This can be my own diagram. So this is a point O and there's a camera right there. So we know the camera is 3 meters away. So what happens, let's say there's a car right there and it is moving downwards. We have a right angle there and there's a right angle there. The car is moving downwards. Okay, so I want to find this rotation of this camera, which is right here, at the instant where it is at this point O. Now what does this exactly mean for this angle, right? Because we know that there's an hypotenuse, and what will happen is that I will eventually rotate the camera so much that its perspective or line of vision is flat, straight. And what does that mean? The degree is actually just 0. It's the angle at which it's viewing the car is 0 radians. And why is it 0 radians? Because the camera's angle which is viewing the car is completely flat. So at this instant, the angle from the camera to the car at point O is actually 0. Now why is this helpful? I will show you. What can I relate? What are two things that I can relate? I have an angle, I have a side. Maybe I can create a tan relationship because I want to find out the speed at which the car moves this distance, let's say the distance x. The speed at which it moves this distance x for a particular time. So can I not say that tan theta is actually equal to the side length x, which is how much it has moved, over the distance 3, which is the camera to the O. This is actually just a trigonometric ratio, opposite over adjacent. Now why is this important? Well, I can now differentiate this, and using implicit differentiation I'll get that sec square theta times d theta by dt, which is actually implicit differentiation. It's a chain rule in this case, is equal to, and I know that is 1 by 3 times dx over dt, another implicit differentiation. Now what does this dx over dt actually represent? It's the speed at which the car covers this distance x over some time, so which is given to me as 24 meters per second. So I can rearrange this equation by substituting, by saying that d theta by dt is actually equal to 24 over 3 times sec square theta. right? This is the relationship for d theta by dt, and I want d theta by dt at the instant where car is at O, and we already know that the angle of the camera's vision at the point O is 0 because it's completely flat. And so instead of theta, I can substitute d theta by dt is equal to 24 by 3, which is just 8, times 1 over sec square theta, and this is actually no calculator, so we have to do this without a calculator. D theta by dt is equal to 8 times, and we know that 1 over sec square theta is nothing but just simply cos square theta, and again I can rewrite it as cos theta times cos theta, and this just makes it simpler to look at, and simpler to see the unit circle. If I have a unit circle like this, I know that at this point right there, that cos theta is actually equal to 1, right? So cos of 0 is equal to 1. I'm substituting 0 sub 0 radians into theta, so 8 times 1 times 1, so d theta by dt is actually 8 meter per second, but that is only if we take its magnitude. If we take direction, we know it's actually going downwards, so it's actually negative 8 meter per second. So thank you for watching. Please like and subscribe. If you have any questions, leave it down below and I'll answer it as soon as possible. Thank you.